So if I asked you to fold a sheet of paper in half, I'm pretty sure most of you could do it. We fold the sheet of paper in half. It's pretty intuitive. And if I asked you to fold it into quarters, I'm pretty sure you could do that too. We just fold a half and a half again. And oh my goodness, lo and behold, we have quarters. But what if I asked you for something slightly more complex? Something like folding into a third. Well, it's a bit trickier. I mean, I guess you could kind of approximate it by, if you just take the sheet of paper and you get it close and then you, oh, okay. And then you push down and, okay, yeah, see? And, yeah. So it's not the best way to do it. And in mathematics and in origami, we like to be precise instead of just hodgepodging it. I'm sure I could have done better, just flatten that first and yeah, there we go. It looks close to a third, but we want exact thirds. So this is how you do it. You take a sheet of paper, you take the top left corner and you fold it down to the bottom right corner, making a firm crease across. Now, I need the middle bottom point, so I'm just gonna crease at the very bottom. I'm gonna fold it in half and just do a little crease there. I'm gonna take the bottom middle point and I'm going to connect it to the top left corner. So I do that, being careful to make sure I have a nice crease. And I'm gonna claim that this point right here, where the diagonal crease and the middle to the top left crease meet, is a third. So let's verify that. We take our sheet of paper, we fold it at that point, and it looks almost like it's a third. Let's fold the other one. And lo and behold, it is a third. Now, what if I wanted to fold a sixth? We know that if we fold it in half, we get a third. So if we fold into a quarter, what are we gonna get? Well, we start off by taking the top left corner and bringing it down to the bottom right corner. We fold it in half to get the halfway mark. And then we fold it in half again to get another crease. And now we take the quarter crease and we connect it to the top left crease, making sure we get a nice exact line. The more exact this line is, the better the actual division of the paper is. And let's investigate to see if this is a sixth. So we fold it at the crease and we get 1 and we get 2 and we get 3 and then we get a 4 and a 5 with the last one. So that didn't make a sixth, that made fifths. If I do the same process and I do go at a quarter, I get a fifth. So if I start at a half and I get a third, and I start at a quarter and I get a fifth, not a sixth, how do you get a seventh or a ninth? See if you guys can't figure that out. Or also, what would I get if I started going the other way? If I started folding the 3/4 mark or the 7/8 mark, one of those, what would I get? See if you can't figure that out. However, the interesting thing though is why this happens. And we'll investigate that next time in the mathematical video. And we'll show you how to actually generalize this to subdivide the paper into any division you want. So check out the next video for that. We can express both of these creases as lines. We have a red line and a blue line. And the point where the red line and the blue line meet is a third. So we need to figure out the equations for these lines. So we'll start off by finding the red line. And we're gonna say